Instrument name: Universal Tensile Strength Tester. Instrument model: M500 30CT. Purpose: to measure the tensile behavior of textile fibers, yarns, fabrics, ropes, cords, belts, and felt material. To measure the coefficient of friction between fabric and metal, fabric and fabric, fabric and rubber, or any flexible thin flat sheet material used in textile products. To measure the compression behavior of various textile materials, example foam or coil sheets for cushioning. To measure the tuft withdrawal force of pile material, that is cut or loop pile. Variable span 3-point bend fixtures are used to measure the flexural test of polymers, composites, etc. One bottom serrated shoe hole grip and one self-aligning shoe peel pincer are used to measure the tensile behavior of shoe. Standard test method conforming to ASTM D3882, ASTM D1294, measurement of tensile behavior of fiber. EN ISO 2062, ASTM D2256, measurement of tensile behavior of yarn. IS 1969, ASTM D5034, ASTM D5035, measurement of tensile behavior of fabric. ASTM D1335, IS 5884, tuft withdrawal force of pile material, that is cut or loop pile. In-house test method: coefficient of friction between fabric and metal, fabric and fabric, fabric and rubber, or any flexible thin flat sheet material used in textile products, etc. In-house test method: measurement of 3-point bending flexural test of composites or sheeting materials. In-house test method: compression test. Measurement of coefficient of friction between fabric and metal. Purpose: to measure the coefficient of friction between fabric and metal. This method is suitable for all types of woven and knitted fabrics. SOP: tensile testing machine is CRE principle based and is provided with the following arrangements. One sled and one slide are provided for friction testing. Sled, upper friction plate, size is 6.3 into 6.3 centimeters and weight is 200 grams. Slide, lower friction plate, the size is 40 into 10 centimeters. Friction slide is attached to the lower fixed jaw and the friction sled is kept above the friction slide. This can be moved over the slide by means of a dragging action by a thread attached to the upper movable jaw of the instrument. A standard validated string thread shall be used which is attached to the upper movable jaw. First attach load cell of required capacity in the instrument and connect the load cell connector pin to the port of the instrument. Next attach slide, the lower friction plate, to the lower fixed jaw of the instrument. Switch on the instrument and the computer. Open the software. The specimen should be cut a bit larger than the slide size to attach it properly. Cut at least 5 warp-way and 5 weft-way test specimens for woven fabric. Condition all specimens in the standard atmosphere of 27 ± 2 degrees centigrade and 65 ± 2% RH. Attach the face side of specimen on the slide by means of an adhesive tape, preventing the tape from covering the testing surface area. Care should be taken for not allowing any creases. Then place the sled on the fabric specimen that is on the slide. Attach one end of standard validated string thread to the sled and the other end to the upper movable jaw of the instrument. For this fabric to metal friction testing, the sled is left without sample attachment so that the metal surface of the sled touches the fabric surface. After that, select the friction test option in the software. Adjust the gauge length to 200 mm and speed to 200 mm per minute. Place the sled to its starting position. Then start the test. On completion of the test, take the readings of static friction force, dynamic friction force, static coefficient of friction, and dynamic coefficient of friction along with the graph from the software. Then remove the tested specimen from the slide and repeat the above procedure for the remaining specimens. Compression test. Method for determination of indentation hardness index. Purpose. Compression test can be used to measure the compression behavior, that is indentation hardness index, of various textile materials, example foam, coil sheets for cushioning. SOP. Tensile testing machine is CRE principle based and is provided with the following arrangements. One upper compression plate and one lower compression plate are provided for compression testing. Size of both compression plates are 200 mm into 200 mm. The lower compression plate is attached to the lower fixed jaw and the upper compression plate is attached to the upper movable jaw of the instrument. First, attach the load cell of required capacity in the instrument and connect the load cell connector pin to the port of the instrument. Then fix the upper compression plate to the upper movable jaw and lower compression plate to the lower fixed jaw of the instrument. Switch on the instrument and the computer. Open software. Cut the required number of test specimens, each measuring 100 mm into 100 mm, leaving a space of 25 mm from the edges of the whole piece. Condition all specimens in the standard atmosphere of 27 ± 2 degrees centigrade and 65 ± 2% RH. Then measure the weight in gram of the conditioned specimen to be tested. Place the specimen on the lower compression plate. Select the compression test option in the software and set the required speed. Example, 50 mm per minute of the movable upper compression plate. Then start to lower the upper compression plate and stop when the upper compression plate just touches the upper part of the specimen. At that time, measure the thickness of the specimen, T, in millimeters. Alternatively, thickness can be measured after conditioning of the specimen. Then lower down the upper compression plate at the speed rate of 50 mm per minute to apply a pressure of 200 grams plus sample weight in grams. Again measure the thickness of the specimen, that is T1 millimeters. Then lower down the movable upper compression plate at the speed rate of 50 mm per minute until the sample is pressed to a thickness of 60% of T1. Record the load for this indentation. This is taken as the indentation hardness index of the specimen. On completion of test, note down the readings and the graph from the software. Then move the upper movable compression plate to remove the tested specimen and repeat the above procedure for the remaining specimens. Different instrument attachments available. Load cells. Load cells with different capacities are available with this instrument. Minimum capacity is 5 Newton and maximum capacity is 30 kilonewton. 5 different capacities of load cells are available. 5 Newton, 100 Newton, 1 kilonewton, 5 kilonewton, 30 kilonewton. Grips. Different grips are available with the instrument for testing various types of textile materials. Different grips are FEBRIC grips and jaw faces. These upper and lower grips and jaw faces are used to measure the tensile behavior of textile fabrics. Fiber grips. These upper and lower grips are used to measure the tensile behavior of textile fibers. Yarn grips. These upper and lower grips are used to measure the tensile behavior of textile yarn. Compression plates. These upper and lower compression plates, size 200 mm into 200 mm, are used to measure the compression behavior of various textile materials. Example, foam and coir sheets for cushioning. Fabric friction attachments. One sled, that is the upper friction plate, size 6.3 into 6.3 centimeters and weight 200 grams. One slide, that is the lower friction plate, size 40 into 10 centimeters, and a standard validated string thread are used to measure the coefficient of friction between fabric and metal, fabric and fabric, fabric and rubber, or any flexible, thin, flat sheet material used in textile products, etc. Cord grips. Pneumatic action upper and lower cord grips are used to measure the tensile behavior of textile cord. Webbing grips. Upper and lower split roller self-tightening webbing grips are used to measure the tensile behavior of textile webbing. Grips for shoe testing. One bottom serrated shoe hold grip and one self-aligning shoe peel pincer are used to measure the tensile behavior of shoes. 3-point bend fixture. Variable span 3-point bend fixture are used to measure the flexural test of polymers, composites, etc. Tuft withdrawal grips. Tuft withdrawal fixture and forceps holder are used to measure the tuft withdrawal force of cut pile material. Tuft withdrawal fixture and hook are used to measure the tuft withdrawal force of loop pile material. Hydraulic grips and hydraulic pump. Hydraulic grips and hydraulic pump are used to measure tensile behavior of high-strength textile materials.